Hi guys, it's Professor Stevens. I'm going to go through some examples from 4.3 by looking at questions which just say to evaluate logarithms. Now, before we go on, I'm just going to make sure that we understand the basic idea of a logarithm. A logarithm is the power to which a base must be raised in order to get the input. That's a very informal definition, but the thing I want you to focus on is that it's a power. So if I have something like 2 to the x equals 8, then the inverse function is the log base 2 of 8 equals x. Okay, so this is the power that you could raise 2 to in order to get 8, right? So we know the answer should be 3, right? 2 to the third power is 8. So if you were to evaluate this expression using the calculator, you would find that it equals 3. Okay, so that's important to keep in mind. So a logarithm is a power. Now we're going to start by evaluating some logarithms. So the first question here is 4.3.1. And the question IDs actually align with questions in the textbook. So you could actually open up your ebook and find question number 1 in the back of the 4.3 section, and you'd find more examples like this one. So we have the log base 2 of 16. And so we're just supposed to evaluate. That's the directions. So this is not an equation, it's an expression. And it's just a numerical expression, really. It's not even algebraic. It doesn't have any variables in it. It's the logarithm base 2 of 16. So what that means is that there's some power that you would raise 2 to in order to get 16. And so I know that that is 4. I know that's 4 because 2 times 2 times 2 times 2 is 16. So I can actually figure this one out without having any fancy calculations. Right? So a lot of times when you're asked to evaluate a logarithm, if you can rewrite it in the form of an exponential equation where your unknown is the exponent, so I've taken an expression which I'm trying to find an answer to. So I mean, you could turn it into an equation if you just wanted to put, say, x over here, and you're looking for x. Well, you're evaluating 2 to what power equals 16. So the answer here is 4. So I'm just going to put 4 here. All right, let's do another one. Let's do log base 3 of 1. What does that equal? We're evaluating. So if I think about it, 3 to what power equals 1? Well, anything to the power of 0 equals 1, so the answer must be 0. How about log base 10 of 0.1? So again, we want to know what this equals. So 10 to some power equals 0.1. 0.1 can also be written as 1 over 10, and 1 over 10 can be written as 10 to the negative 1, which means that the answer is -1. Okay, up here the answer was 0. All right, maybe one that's a little bit more interesting. How about log base e of 1 over e squared? So I can rewrite that as the log e of e to the negative 2. So if I want to rewrite that as an exponential, that's e to what power would give me e to the negative 2. And then you can see that now, of course, the exponents match, so the answer is negative 2. And later we'll start working with identities where you could look at this thing and know right away that the base e is going to cancel with the base of this exponential input. They actually end up, in effect, canceling each other out. But we'll look at those identities later in chapter 4. 2, how about log base 2 of the square root of 2? And I can rewrite that as log base 2 of 2 to the 1/2 power. And if I rewrite this now as an exponential expression, that's 2 to some power equals 2 to the 1/2 power. And so therefore the answer is 1/2. Now I've just been using a box, but you can actually you can give your unknown a name, you can give it and then it makes sense, x to the 1/2. I mean x equals 1/2. All right, so I think that's enough examples on that objective. Let's now look at the objective to write a statement from exponential form, change it into logarithmic form. Right, so we've been doing this already, but now before we were doing it in order to evaluate a logarithmic expression. Now we're going to do it just for the purpose of rewriting it in another format. So rewrite the statement given in exponential form. Well, how about just to say, I'll write it like this: rewrite the given exponential statement in an equivalent logarithmic form. Okay, so this would be in the textbook, question ID 4.3.3 is what it starts with, and they go through to number 6. And then there are some that are the other way around. So meaning that we'll start with logarithmic and we'll rewrite it as exponential. So now that I noticed that they do both here, I'm going to say the directions are: rewrite the given statement in exponential or logarithmic form. So we're basically just converting. So whatever you are given, convert it to the other type. Okay, so convert the given statement to exponential or logarithmic form, and that would be 3 through 10. All right, so number 3 is 3 to the power 4 is 81. So in logarithmic form, see, it's in exponential, right? So I'm going to change it to the other form. So now I'm going to use the same base. So I'm going to have log base 3, and then the 4 and the 81 have to switch sides. So now it's log base 3 of 81 equals 4. And that's the answer, because we're just rewriting it in an equivalent form. 4 is given in exponential form. It is 2 to the 5th power equals 32. So in logarithmic form, it'll be the log base 2 of 32 equals 5. Number 5, 2/3 to the third power, negative third power, is equal to 27/8. So that's exponential form, so I'm going to do it as log base 2/3 of 27/8 is equal to -3. Now, the last one here, 10 to the -4 equals, so I can convert that to the log base 10 of 0.0001 is equal to -4. And technically, you don't need to write the base 10, because if ever you see just log without a base on it, like say this expression, although the base is not mentioned, we know by default that it's 10. It's kind of like when you see the square root of 4, the index is 2 on that, but we don't write that. We don't write the 2. It's assumed. And then if you have a different root, like a third root, a cube root of 8 perhaps, then it's necessary to put the 3 there, because if there's nothing, it's defaults to a second root. Yeah, there you go. You get it? Okay, good. Okay, so now let's do some that are the other way around. So we're starting, they're giving us one that's in log form, say log base 6 of 36 is equal to 2. And then we convert, we say that 6 to the power of 2 equals 36. And yeah, that's true, right? 8 log base 5 of 5 equals 1 converts to 5 to the power of 1 equals 5. True. Okay, so remember we said the informal definition is that a logarithm is the power that you would raise the base to in order to get the input. Right, then 9 is log base square root of 3 of 81 equals 8. So that can convert to the base square root of 3 to the power of 8 equals 81. You can check this too. The square root of 3 to the power of 2 to the power of 4. So in here now you have the power of the square root cancels with the power of 2, and then you still have 4 on the outside. So that's 3 times 3 is 9. So 3 times 3 times 3 times 3 would be 81. Okay, so these are easier to check than the writing them the other way around. We're more familiar with exponents, so it's easy to check it, make sense of it in your own mind. Oh, I started converting already. So this last one is given as log base 4 of 1 over 64, which can be rewritten as the base 4 to the power, oh, I forgot to put the other side of the equation. And this is what we're doing. So we're doing 4 to the power of -3 equals 1 over 64. And then to check if that makes sense, remember if you have a negative exponent, you can rewrite it as the reciprocal. Technically it would be like this first. When you flip the base, the exponent changes sign. And then if you distributed the power of 3 to 1, you would still get 1. And distribute the power of 3 to 4, and you would have 4 cubed, which will turn out to be 64. Okay, so those are all the easier ones There's more complex ones, like how about number 31? But this, are we still doing conversions? No. Now the next objective is to actually solve logarithmic equations. So this video, I'll leave this video just about evaluations and rewriting, converting between the two forms. And we'll start some of the next objective in the next video.